Right, here we are at the top of page 3 of 4.6, our last page of our last set of notes. And we're going to start off with a reminder from the book. Sorry about the typo there, should just be 1P. Page 274 talks you through the author's version of how to graph a linear equality in two variables. You might give that a read through. It might help make things even more sense than they do right now. Hopefully this section has been fairly straightforward for you. If you're still kind of working on your graphing skills from earlier in the chapter, maybe this will help solidify it. We'll move on to some practice plus problems as we finish up here in this section. And so we can expect two things at once. Not only what we're doing now, which is graphing linear equalities, but something else we've done before. And in this case, it'll be to translate. So they're going to have us translate to a linear inequality in two variables, means we can expect an x and a y to be involved. Then we'll go ahead and graph it. So two parts to this problem. So we're going to start by reading, taking a deep breath, read again, and keep our goal in mind. So the goal is to come up with a linear inequality, meaning it's going to have something of this form, y equals mx plus b, or something like that, or maybe it'll have a ax plus by and c, and this will either be a less than, greater than, less or equal, greater than or equal, less than, greater than, less or equal, greater than or equal. So one of those two forms is kind of what we're expecting to see. So let's see what it says here. The difference between the x variable and the y variable is at least 3. Sorry, it got a little bent there, but that should say is at least 3. So let's read it again. Deep breath, read it again. The difference between the x variable and the y variable is at least 3. Well, the is pops out right away. That would be where our equal sign would go. In this case, we're going to choose between less than, greater than, less or equal to, greater than or equal to. Other thing that pops out is the word difference, which means we're going to subtract, and it's always the first item mentioned minus the second item mentioned. So they're talking about difference between, here it is, here's our x variable, so this is the first item, and the y variable, so there's the second item mentioned. So it will be x minus y is at least 3. So at least is our inequality. So at least 3 means that it could be, so which one is it? Is it less than, greater than, less or equal to, greater than or equal to? Well, if I'm not sure, or if I haven't memorized these phrases, what means what, then I give myself some examples to convince myself. So some number examples to convince myself of which one to choose. In this case, at least 3 means that I could be 3, or I could be 4, I could be 10, I could be 12. I could not be, 0. 0 is not at least 3, or 2, or negative 11. So I can't be any of those. That would not be at least 3. At least 3 means I could be 3. That would make that true. I could be any number above 3. So 3 or above is what I'm talking about. And that's going to make me pick this for my is at least. So I'm going to end up picking the greater than or equal to. So the translation I've got here is the difference between the x variable and the y variable is at least 3. Okay? Now they ask us to graph it. So we've got our translation. In fact, it turned out to be a translation in standard form. But we would like the slope-intercept form to be able to graph. So I'm going to rearrange this here, and I'm going to start with x minus y is greater than or equal to 3. Sorry, I didn't leave myself enough room here. Let's subtract x from both sides, and I get negative y is greater than or equal to negative x plus 3. And this is where it's very important to kind of follow your inequality down here, because now I'm about to divide everything by -1, and this should be sending off bells, whistles, red flag, well in this case blue flags here, I'm using a blue pen, but I divided everything by a negative. That's going to flip that inequality. Now instead of greater than or equal to, it's less than or equal to. And I end up with y is less than or equal to, let's make sure I'm still on screen here. Adjust just a little bit. Make sure you can read that okay. Y is less than or equal to a positive x minus 3. Now this is graphable. I've got an intercept of -3. 0, -3 is the intercept. I have a slope of 1, so it's up 1 over 1, up 1 to the right 1, up 1 to the right 1, That's the same as if I'd gone down 1 to the left 1. -1 over -1 would be the same as +1 for a slope. I can connect this line, but before I do, I make sure that I know if I'm doing solid or dashed. In this case, it will be a solid line. And because of the flip and the inequality, I'm thinking that the less than means underneath. I'm just going to double check that with a test point. So my test point of 0, 0 here, if that works in my inequality, if it makes it true, then I would shade either side. And you could even do it back in your original or the one you've solved here. So back in the original, 0 minus 0 is greater than or equal to 3. Nope, turns out false. Let's try it in the rearranged version. 0 is less than 0 minus 3. 0 is less than or equal to -3. Also not true, so it's a false statement, so I end up shading the other side of the line that did not include the test point. And that's what I get for my graph. That was my practice plus I translated to my inequality and then I graphed it. And either of these versions in the translation would be fine. X minus y is greater than or equal to 3, or x is less than or equal to, or I'm sorry, y is less than or equal to x minus 3. Okay, we'll move to the next video, bottom of the page, for one that you get to try.